Today, we're going to explore two fascinating climate processes, El Niño and La Niña, powerful natural events that can change global weather patterns, disrupt ocean currents, and impact communities around the world. These events are part of a larger system called the El Niño-Southern Oscillation, which causes irregular changes in the ocean's temperatures and wind patterns across the Pacific Ocean. Let's break down how each one works. Under normal conditions, trade winds blow from east to west across the tropical Pacific. These winds push warm surface water towards Australia and Southeast Asia, while cold, nutrient-rich water from the deep ocean rises along the coast of South America, a process known as upwelling. This circulation of warm and cold water is part of the thermohaline circulation, helping to balance ocean temperatures and support ecosystems. The warm western Pacific brings heavy rainfall to places like Indonesia, while the cooler eastern Pacific stays dry and stable. Every few years, these trade winds weaken or even reverse, allowing warm water to drift back eastwards towards South America. This is the El Niño phase. As a result, the eastern Pacific becomes much warmer than normal, while upwelling of cold water slows down. This can have major impacts, including heavy rainfall and flooding in normally dry areas like Peru and Ecuador, droughts and wildfires in places that usually get rain, such as Australia and Indonesia, and the collapsing of fishing stocks off the South American coast because the warm water reduces nutrients, disrupting the fishing industry that millions of people depend on. El Niño can even shift global weather patterns, leading to warmer winters in North America, weakening of the monsoon season in India, and even increased storm activity in some parts of the world. La Niña is the opposite extreme. Here, the trade winds strengthen, pushing even more warm water westward than usual. This causes colder than normal waters to rise near South America, increasing upwelling and making the eastern Pacific unusually cool. Here, the effects are reversed. Droughts in South America, but heavy rain and flooding in Australia and Southeast Asia. Stronger Atlantic hurricanes, as cooler Pacific winds allow the global circulation to shift energy elsewhere. And in the UK and Northern Europe, La Niña years can bring colder, snowier winters due to changes in the jet stream. Both El Niño and La Niña cause chain reactions in the atmosphere that affect the global climate system. These can change temperature patterns, monsoons, and rainfall thousands of miles away. For communities, the effects can be devastating. Farmers suffer crop losses from drought or flooding. Fishing communities lose income when marine ecosystems collapse. And governments face challenges when preparing for floods, wildfires, or even food shortages. Because these events can last for months, their impacts can ripple through global food prices, water supplies, and even migration patterns. Scientists understand the basic mechanics of El Niño and La Niña, but predicting their timing, strength, and duration remains difficult. The ocean atmosphere system is incredibly complex, and small changes can have huge impacts. Climate change may be increasing the frequency and intensity of these events by warming the ocean surface and altering wind circulation patterns. Some models even suggest that stronger El Niños could become more common, bringing more extreme floods and droughts, while others warn that La Niña events might also intensify. What scientists can agree on is that climate change is adding uncertainty, making it harder to predict how southern oscillation events will shape future global weather. So whether it's El Niño warming the Pacific or La Niña cooling it, these shifting ocean currents remind us just how interconnected our planet really is. A change in one part of the ocean can trigger droughts, floods, and storms across the globe, and as our climate continues to warm, understanding these patterns has never been more important.